Hello everyone. In this video, we'll discuss about analog to digital converters. Normally here in analog to digital converters is used to convert the analog value to a digital value. Okay, for example, if your output is of analog, but you have to interconnect to the system which accepts only the digital values, we can use this analog to digital converters. First, we'll go with the applications, measurement and control system. This is one of the applications of analog to digital converters. For example, in control system or any measuring units, we can use this analog to digital converters. And industrial instrumentation, and every industries will just have this ADC, right? Because maximum the system, right, the computers or any systems, it will accept only the zeros and ones, that is the digital values. Okay, so that is the reason that is that is the main advantages of an ADC. Next, communication system. Communication systems also maximum the digital values are used, so at that time we can use the ADC. Then sensory based systems. Okay, in sensory based systems, in sensors, right, there was this digital sensor and analog sensor. Digital sensor is simpler, that is either if it is detector, it will be the output will be 1. If it is not detector, the output will be 0. That is, if it detects it, you'll get the output. Not detected, you'll not get the output. So at that time, the digital values is obtained, right? So here also the digital values plays a vital role. So here we'll come for the classification. Classification of ADC. We have two types: direct type ADC and integrating type ADC. In direct type ADCs, we have flash type converter, counter type converter, tracking or server converter, successive approximation type converter. These are the classification. Okay. Next, we'll see what is integrating type converter. An ADC converter that performs conversion in an indirect manner by first changing the analog input signal to a linear function of a time or frequency, then to the analog is known as integrating type of ADC. For example, linear function in the sense, what is linear? For example, if your input increases, the output will increases in that manner. That is linear. It will not increase in the square or root, right? It will just increase in linear function. That is in linear manner. If you plot the graph, it should be linear. Okay, that is the linear function. So here in integrating type converter, it will perform an indirect manner. Okay, by first we'll change the analog input signal to a linear function. Then we'll convert into a digital code. Next one is flash type converter. Here you can see the flash type. In flash type converter, we use comparator. Okay, this is the comparator. This is the comparator, right? We have used n number of converters and we have used a encoder here. Which encoder here we have described here is 8:3 priority encoder. 8:3 encoder. So we are connecting the n number of comparators to encoder to get the binary output. Okay. Okay, for example, you can just refer this. If the comparator, you'll get the values and it given to the encoder, and the process will be done according to the encoder, and you'll get the binary output. Next comes the successive type approximation type converter. Here also the converter is used. So the comparator is used. Okay. Comparator, the output from the comparator is given to the successive approximation resistor, right? We have given to successive approximation, then we are given to a DAC, then the feedback is again given to the comparator. You can just check. Okay, successive approximation type is given to DAC and the DAC is given to feedback, given as the feedback to the comparator. Okay, and the clock signal also given here. You can just verify the clock signal is also given to the successive approximation type register. Okay. So like this, for example, what is MSB, LSB? Already I think we know, right? The successive approximation type register, the output here obtained here is the LSB, that is most significant bit. The at last the obtained one is least significant bit. Okay. Likewise, your output will be obtained. So these are the two type of converter we have discussed, and okay. Sorry. This is your just we'll discuss this question. What is the list of the type of ADC? Already we have discussed the ADC, right? What is the type of ADC? I first started with the ADC, right? Types. So these are the types of ADC. We have two types, direct type and integrating type. Okay. In direct type only we have flash type converter, counter type converter, tracking and server converter, or successive type converter and successive type converter. Okay, these are the types. Okay, this is ADC, that is analog to digital converter. We have another type of converter, that is analog to digital. This is analog to digital converter. We have another type, that is digital to analog converter. In analog to digital converter, it converts analog value to the digital value. Okay, it converts in this DAC, it converts the digital value to the analog one. For example, if you are getting the digital value, but depends on the applications, right? Example, if your application needs the analog value, it can be able to convert. Okay, it will convert the digital values to the analog values. Okay, so that's all with this ADC. So thank you.